Welcome to today's Explainer, where we're going to dive deep into a hidden world and totally shatter the wireless illusion of our modern digital lives. Let's just jump right in, because what we're about to explore is the incredibly complex, completely invisible physical infrastructure that actually keeps our world spinning.
I want you to ask yourself a really simple question. Seriously, think about it for a second. Where does your data actually go when you send an email, stream a video, or make an international bank transfer? Because despite what all those slick marketing campaigns tell us, it is definitely not magically floating up in the sky.
We love talking about the cloud, right? But the reality is entirely different. Your phone or your laptop, it's only connecting wirelessly to a nearby cell tower or a local router. From there, the vast majority of your long-distance and international traffic is beamed as pulses of light across the physical bottom of the ocean. Yep, the seafloor is the actual physical reality of the internet.
All right, part one. Inside the ocean's backbone.
To wrap our heads around the breathtaking scale of this infrastructure, which NATO literally describes as the backbone of modern society, we have to look at our true dependency. Get this, an astonishing 95 to 99% of all intercontinental internet traffic travels through undersea telecommunications cables. We're talking about more than 1 million kilometers of fiber optic lines just resting out there in the deep, dark ocean.
And it's not just cat videos and social media. These cables are the absolute lifeline of the global economy, supporting roughly 15 million daily financial transactions. That equates to about $10 trillion flowing through these submerged glass tubes every single day. Literally, if these cables stop working, international banking, trade clearance, and global markets just grind to an absolute halt.
Now, this isn't exactly a new idea. The network actually conquered the oceans way back in 1858 with the very first transatlantic telegraph experiments. Over the years, that evolved through telephone cables all the way to the optical amplifiers we use today. But here's a really crucial distinction. Modern cables don't contain the internet inside them. They are the highways connecting massive data centers, national networks, internet exchange points, and cloud systems. And today, privately financed hyperscale systems from tech giants like Google, Meta, and Microsoft are the ones pouring massive capital into building and maintaining this physical backbone.
So what are they actually laying down there? Well, picture a cable about the size of your standard garden hose. Right at its core, it houses these hair-thin optical fibers that carry hundreds of terabits of data per second. Those tiny strands are surrounded by a copper conductor that supplies power to repeaters, which you absolutely need to amplify the optical signal over routes that are thousands of kilometers long. All of this is encased in thick insulation and protective steel wire, featuring heavy armor near the coasts and a lighter construction out in the deep water.
Which brings us to part two, the anchor problem.
Despite all that heavy armoring in shallow waters, these vital cables are incredibly fragile. You hear a lot of sensationalist narratives in the news about targeted sabotage, but the mundane truth is that the vast majority of damage is completely accidental. Sure, environmental factors like underwater landslides, earthquakes, and just general component aging play a role, but commercial fishing equipment, dredging, and dragged anchors account for roughly 70% of all faults. Normally, around 150 to 200 outages occur every single year. In fact, in 2025 alone, more than 170 repairs were reported. That is nearly 4 broken cables every week.
You see, an anchor doesn't even need to strike a cable precisely to cause a complete disaster. A single commercial vessel dragging its multi-ton anchor along the seabed can just catch a cable and pull it until it violently snaps. And in tight, crowded maritime corridors, a single ship can drag across the seafloor and take out several neighboring lines in one go. When that happens, it creates a massive, chaotic repair backlog for the entire region.
Moving on to part three, sabotage and gray zone threats.
Now, even though most damage is undeniably accidental, geopolitical tensions are absolutely rising. Governments are getting really concerned about deliberate gray zone operations. If we impartially look at recent incidents in the Baltic Sea, there's a clear pattern of severed infrastructure that has international alliances on high alert. In late 2023, a vessel named the New Polar Bear dragged its anchor, damaging data cables and a gas pipeline. Fast forward a year later, the Yupeng 3 severed 2 undersea data cables in the same region. And then, in December 2024, Finnish Special Forces actually boarded an oil tanker, the Eagle S, after it dragged its anchor for 66 miles straight toward critical infrastructure.
The real nightmare here, the central difficulty in these gray zone operations, is attribution.
A civilian-looking commercial vessel dragging an anchor out of pure, everyday negligence looks practically identical to a vessel executing a state-sponsored attack, because automatic identification systems can easily be disabled or manipulated, and detailed cable maps are just commercially available to anyone. Malicious actors can cause catastrophic damage while staying just below the threshold of conventional warfare. Proving intent is incredibly difficult.
So, Part 4. Resilience and Deep Sea Repair.
With all these anchors dragging and potential sabotage happening, you might be wondering, why doesn't the internet just immediately switch off when a cable breaks? Well, the answer is redundancy. The network just reroutes your traffic through alternative cables. Countries served by a ton of diverse routes are actually pretty resilient. The real, terrifying danger lies in concentrated dependencies. Islands or countries connected by very few cables or completely dependent on a single landing station are highly vulnerable. Take Alexandria, Egypt, for example. An astounding 80% of all connectivity between Europe and the Middle East passes through a single building in this massive geographic choke point. If multiple cables sharing that same narrow route are cut at the same time, the backup capacity is exhausted, and entire regions can literally go dark.
But when a break does happen, repairing the internet out at sea is this incredibly fascinating, painstaking operation. First, operators back on land have to shoot electrical and optical measurements down the line just to locate the exact fault. Then, a highly specialized ship sails out to the area, dragging massive grapnels to haul the damaged cable all the way up from the seabed. Once it's aboard the ship, engineers remove the damaged section, meticulously fusion splice a replacement segment of glass fibers back in, test the connection, and then carefully, slowly, lower it back into the ocean. This whole process can take weeks as crews battle harsh weather, navigate complex permit approvals, and contend with extreme water depth and the super rare availability of these specialized repair ships.
Part 5. Defending the Invisible Network.
With trillions of dollars literally on the line, international coalitions are rapidly deploying new strategies to protect this indispensable infrastructure. Tech companies are desperately investing in route diversity, additional landing stations, and burying cables much deeper near the coasts to avoid those choke points. Militarily, alliances like NATO are running continuous maritime patrols like Baltic Sentry and constantly tracking vessel behavior. Meanwhile, the European Union has rolled out a massive four-stage strategy: prevent, detect, respond and repair, and deter, allocating €347 million to cable security projects and repair capacity for 2026 alone. Technologically, operators are even deploying subsea acoustic sensors, autonomous seabed vehicles, and getting ready to reroute critical data to space satellites during a major crisis.
So, wrapping things up, the big takeaway from this explainer is that our undersea cables combine three very uncomfortable realities. First, they are physically fragile. Second, they are geographically concentrated in tight, vulnerable choke points. And third, modern society absolutely cannot function without them. The real story isn't just that a single anchor can switch off the entire world, it's that almost every digital system we rely on ultimately depends on physical infrastructure most people will never even see.
So the next time you seamlessly stream a 4K video or instantly send money to someone on the exact opposite side of the planet, take a second to ask yourself, just how secure is this $10 trillion invisible highway really? And can a handful of countries truly protect a fragile network that spans millions of miles across the deep, dark ocean? Thanks for exploring this hidden backbone with me, and as always, keep questioning the world around you.